All right, hello everyone. In this video, we're going to be looking at how to find the resultant. So the resultant is just a fancy way of saying the sum of two or more vectors. And so there's two different ways that we have to add vectors. We can either add them graphically, or in other words, the head to tail method. Or we can add them by components. Okay, so let's suppose we have two vectors, A, which is 11 meters at 47 degrees, and B, which is 17 meters at 94 degrees. So if we want to add these graphically, we simply draw both. So draw one first, starting from the origin. Draw the second, starting at where the first one terminated, and the resultant, or the sum of the two vectors, starts from where you started drawing the first vector and ends where you finished drawing the second vector. So we can show that fairly easily. So by the way, these are in what's called standard form. So we were just given a magnitude and an angle. And if there's nothing to reference the angle from, then we assume that it's measured from the positive x-axis. Alternatively, we could have been given the vectors in component form. So much along the x direction, so much along the y direction. Or we could have been given them with references for the angles. So for instance, 11 degrees north of west or whatever. Okay, so let's draw these vectors. So when you're finding the resultant, it turns out it doesn't matter which one you start with. So let's start with 11, or let's start with A rather. So A is 11 meters at 47 degrees. So like I said, this is measured from the positive x-axis. So that looks something like this. This angle is our 47-degree angle, and this length is 11 meters. So, but we don't want A, we want the resultant, or A plus B. So now we draw B starting from where A finished. So B is at 94 degrees, so we can draw like an imaginary little coordinate system here. So 94 degrees is in this second quadrant here. So the vector B looks something like this. So this is 17 meters, and this angle is 94 degrees. And now our resultant, or A plus B, starts from where we started drawing the first vector and ends where the second vector finished. So this is the vector R, which is A plus B. Now this method of adding vectors is not very practical. You need a ruler and some sort of scale to translate 11 meters to what can fit on a page, and also a protractor for making sure the angles are very precise. So the way that you'll actually add vectors on a test or in any practical scenario, is that better? So the way that we'll actually do it is by components. So if we draw vector A again here, A looks something like this. So this is 47 degrees. We can see that this vector is the sum of two vectors. So some vector along the x direction and some vector along the y direction. So we can call this AX and AY. And we can see if we just did the tip to tail method, this AX vector plus the AY vector would give us A. And so we can find these components. We can either use this right triangle here, or we can use the rule that we know that the X component is always the magnitude, which in this case is 11, times cosine of the angle from the positive x-axis. So luckily that's the angle that we were given initially. So this is AX, and AY is the magnitude times sine of the angle from the positive x-axis. So if you plug this in your calculator, you'll get 7.5 meters for the X part and 8.0 meters for the Y part. So these are the components of A. So we can write this vector as the X part, which is 7.5 meters along the X direction. the unit vector along the x direction is called I hat, plus this 8 meters along the y direction, and the unit vector in the y direction is j hat. So we can do the same thing with B. So B was at 94 degrees. So this angle is 94, and it was 17 meters. So just like we did with A, the x component of B is this 17 meters times cosine of 94 degrees. And the y component for B is this 17 meters times sine of 94 degrees. Okay, so if you do plug this in your calculator, you'll get negative 1.2 meters for the x and 17.0 meters for y. Okay, now what we want is the resultant, which is A plus B. Now to add these vectors by components, we just add the x parts, and that's along the x direction, and we add the y parts, and that's along the y direction. So in other words, the x component for the resultant is ax plus bx, and that's along this I hat, and the y component is ay plus by, and that's along this j hat. Okay, so we just found what these things were. Here's bx, and we calculated ax up here. So we just add these things together, and if you do that, then you'll get that the resultant is 6.3 meters in the I hat direction plus 25.0 meters in the j hat direction. Now we're not quite done. Because we were initially given these vectors in terms of magnitudes and angles as measured from the positive x-axis, we should also spit out our answer in that same format. So we need two things. We need the magnitude of this vector, and we need the angle as measured from the positive x-axis. So that's easy to do. We can symbolize the magnitude of this vector either by using bars, like absolute value bars around the vector, or just by writing the letter without the vector sign above it. And we can find that from Pythagorean theorem. So if we draw this vector, x is positive and y is positive. So it's in the first quadrant, and it's mostly along y. So it looks something like this. So this x part is this vector here. So this is the distance 6.3 meters. And this distance is our y part, which is 25 meters. So our magnitude is the length of this line here. So we have a right triangle, and we can just use Pythagorean theorem. So that's the x part squared plus the y part squared, all under a square root. So if you do that, you get 25.8 meters. And now we need the angle as measured from the positive x-axis. So luckily for us, since we're in the first quadrant, that's just this angle here, right? And so this is a right triangle. We can find this angle using arctangent. So tangent of this angle will give us opposite over adjacent. So if we do the arctan of this opposite side, which is 25 meters, divided by this adjacent side, which is 6.3 meters, then what we get is 75.9 degrees. So in other words, our resultant then is our magnitude, 25.8 meters at 75.9 degrees. Okay, so that's how you find the resultant.